building a cylindrical barrel, putting Dr. Brent, whoever that is, so you can float him over the Niagara Falls. Apparently Dr. Brent wrote this. I can fit in a barrel with volume equal to 1 cubic meter. The material for the lateral surface area costs $18 per square meter. Material for the circular ends costs $9. What is the exact radius and height of the barrel so that the cost is minimized? Okay. So, first of all, draw a cylinder. Which is just like a pop can, basically. There's your cylinder. They tell us that the material for the top and the bottom, the circular ends, is $9 per square meter. So this is $9 per meter squared. And for the side is 18. Okay. Anybody know what the formula for a cylinder is? Yes. Pi r squared h. Okay. And if you think about a cylinder, you can break it into 2 bits. Basically, this is a cylinder. If you wrap it, right, and then you unwrap it, you get a rectangle. Okay? And this top, you know what you call the outside of a circle? All the way around? Circumference. The circumference is equal to the length of the rectangle. And then the height is the height. Okay? So this essentially breaks into a rectangle, which is the sides. And the circumference, anybody know what the formula for circumference is? 2 pi r. 2 pi r. And the height is the height. And then you have the top and the bottom, which are just circles. And area, there's 2 of them. Area equals pi r, not pi over r squared, pi r squared. Okay, so we have our volume formula. We are trying to, so we have to do a surface area formula. This is why I did this. I will give you the formulas, but I want to show you where they come from because I don't think I talk a lot about that in math. So if I ask for the surface area, just in general terms, what is the surface area? It's just area of all the surfaces. That's why it's called surface area. What are the surfaces we have? We have 2 circles. So it's going to be 2 times the area of the top bit, because the bottom bit will be the exact same, plus the area of the sides. The area of the top is pi r squared, because it's a circle, and there's 2 of them. So that'll be 2 pi r squared plus, exactly. So this rectangle, which is the side, area of a rectangle is the length times the width, or the circumference times the height in this case. So it's 2 pi r times h. And that is the surface area formula for a can, a cylindrical can. Now, the reason I did that is because they give us how much it costs per square meter, per area. So I need to generate a cost formula. Okay. How much does it cost to build the top of the can? Top and bottom. $9 per square meter. This is how much I have in the square meters, right? So it's $9 times the area, which is 2 pi r squared, plus what? $18 for the sides times how much you have. So 2 pi r h. So obviously this can clean up to 18 pi r squared plus 36 pi r. What are we trying to minimize? The cost, right? So that's the formula we're going to want to derive. However, what's wrong with the formula as it's written? We have two variables. We have r and h. But we do have this, all right? And they state that Dr. Brent can fit in a barrel that has a volume of 1 cubic meter. So essentially they're saying 1 cubic meter, I guess, is equal to pi r squared h. Or 1 is equal to pi r squared h. So you need to pick a variable to solve for. Because we're going to use the volume formula to sub out one of the variables here. What would be, it doesn't actually matter, but what would be the easiest one to solve for? H, right? Because if I solve for h here, 1, I don't have to square root anything. And 2, there's only one h here, so you only have to make one substitution. You could solve for r, or r squared, and sub it in, but you're going to have to make 2 substitutions. Okay? So if I solve for h, I get 1 over pi r squared equals h. And then that goes right there. So now my new formula is the cost is 18. And instead of h, I write 1 over pi r squared. And then you want to clean it up. So 18 pi r squared. 36, what's happening to the pi's here? They will cancel, right? And this r will cancel one of those r's. So I get 36 over r, which I don't want to write that way. I'll write it as 36 r to the minus 1. There. Now we have a cost equation that only has one variable, r. We're trying to minimize the cost, so our next step is to derive it. Go for it, peoples. Derive it, and then prove it's a max or a min. I'm going to freeze this, and then I'll put the answer up in a sec. Cube root of 1 over pi. Here's my derivative. Set it equals 0. Move that over, multiply that up. 36 to the pi. 36 cancels, sorry. You get 1 over pi is equal to r cubed. Cube root both sides, you get about 0.68. Yes? And then you just have to prove that that's a max or a min. Your choice of what you want to do. First derivative, decreasing, increasing, it's a min. Second derivative, there's the second derivative. Put 0.68 into it, you get a positive number which has its concave up, which means it has to be a min at the critical point. And then if you want to find h actually works out to be basically the same number. Any questions about that? Because I divided this off to here and multiplied the r cubed. Okay? Going like this. So those came down and the R squared up. Right? We okay? All right. I've got 2 questions to do here. I'm going to give you.